Hi, we're going to be talking about section 8.4, confidence intervals when the population standard deviation is not known. All right, so what we've been working on in the beginning of this, of chapter 8 has been around the idea that if we have a sample mean and x bar minus mu divided by sigma over the square root of n, is a standard normal distribution, right? So that is a true statement, but what if we do not know the population standard deviation? Then we maybe could substitute in the sample standard deviation, and we can do that, but it changes the distribution. So it no longer has a normal distribution, it has another distribution, which we call t distribution. Okay, and so the t distribution is based on the idea here that if I calculate this statistic, x bar minus mu divided by s over the square root of n, that this guy has a t distribution. So I want to tell you a little bit about the t distribution. So I'm going to share my screen. Okay, so the t distribution is, well, actually, let me just kind of show you. The black is the normal distribution. So we can kind of just sweep through that feeling, okay, at least there's something I know here, right? Here's the normal distribution. The black is the normal distribution. And then let's start with the orange. That's the t distribution, but there are t distribution is a series of distributions indexed by something called degrees of freedom. So orange is the t distribution with 1 degree of freedom, purple is 2, and blue is 5. So what are degrees of freedom? Well, that's going to depend on sample size. So we'll continue to investigate as we go further regarding that. But so yes, so which of these curves you would be on depends on your sample size. But what happens is as the sample size increases, the degrees of freedom increase, and the distribution of t gets closer and closer. We say in math converges to this normal distribution here. Okay. I also just want to pull up the formula card. So this is like the last page in your formula card. So if you can do as well, please open your formula card or pick it up. Or okay, so what we have here, notice there's a picture of what we have here. So this is values of t sub alpha. We'll have pictures on the whiteboard in a minute. There's a picture of a right tail. So the t distribution table is a right tail table, right? Remember that the z distribution, the normal distribution, was a left tail table. So we will use this in a little different way, and actually it's easier because you don't have to do the indirect lookups at all. Okay, so I'm gonna come on over to the whiteboard. Okay, so what we know is that if we standardize using this formula here, then we're going to end up with a t distribution. So now we want to be able to make confidence intervals based on the t distribution, because sometimes we won't know the population standard deviation. Actually, that's usually the case. So just a little bit about the basic properties of the t curve. The total area under the curve is 1, right? So that total area is 1. And the curve extends infinitely in both directions, approaching but never touching the horizontal axis. So that's very similar. It's exactly the same as the normal. Actually, it looks a lot like the normal, except it has those fatter tails, so it's shorter and fatter in the tails, right? It is symmetric about 0. And as the degrees of freedom increases, the T curve tends to the standard normal. It converges there. So we saw that in the pictures. Okay. So I just want to go through a couple of examples so that we can get used to reading from the T table. And the first one is for 15 degrees of freedom, find T, so 0.05. Okay, so let me write that down. So I'm going to draw a nice curve, bell-shaped curve. T is also bell-shaped, right? So it's a bell-shaped curve. And it's not Z, it's T here. And it's T with 15 degrees of freedom. And we are looking for the 95th percentile. I'm sorry, we're looking for T sub 0.05, which I state is also the 95th percentile. So this is what we're looking for. We know the area to the right is 0.05. And my little comment there was that it's also the 95th percentile because the area to the left is 95, because 1 minus 0.05 is 95. So, but that's really wasn't the point of the exercise. We're going to go over to the table and find that value of T that has 15 degrees of freedom and 0.05 to the right. So I'm just going to come on over and share the screen again. So please open up your formula card in whatever format you have it and follow along. So degrees of freedom are 15. I see that right about here. And if I go, this is let's make this a little bigger. And we want 15 degrees of freedom. So we're in here somewhere, right? And look up here for the subscript on the T to determine which row you want to be in. We want to be in this row, right? So really, it's this guy here. So it's in the row, I'm sorry, excuse me, from the row 15 and in the column determined by 0.05. And so we have that value we're looking for is 1.753. So let me put that up on the whiteboard. T, so 0.05 equals 1.753. Okay. All right. So let's go ahead and do the other one as well. For 28 degrees of freedom, find T sub 0.01. Okay, I'm going to pause if you guys give it a shot, and I'll put it up on the board. You can pause as well. Okay, so we're looking for the next lookup that we're going to do on the T distribution. We're asked to find T sub 0.01. And this is just a picture of what that is. The degrees of freedom are given as 28. So this is a T with 28 degrees of freedom. That's this curve. Okay, and we're looking for T sub 0.01, same notation as the Z sub alpha, T sub alpha, which means that we want 0.01 area to the right. Okay, so go on into the table. Let's do a quick look on that. So please open your table. And we have 28 degrees of freedom. And we're looking for T sub 0.01. So it's going to be in this column here, but I got to scroll it down to 28 degrees of freedom. I'm getting 2.467. You guys check. I'm doing this for the first time here, so I could have these wrong. 2.467. As a matter of fact, I'll do one more check. Easy to it's good to check these twice on exams as well. It's real easy to, yep, 2.467, that looks good. Okay, so that's how you read from the T-table. So I'm gonna stop the video and we will come back with part 2. And in part 2, we're gonna use the T value in a confidence interval problem. And we're gonna also learn how to read a problem to determine whether we should use a Z or a T interval. So those are our 2 goals left in this section.